Good evening to everyone. So, welcome to this traffic engineering interactive session series. So, this is week 9, and today uh, we shall do this traffic control and management module, which is the week 10 module of traffic engineering NPTEL course. So let's start with some basic concept that has been covered in the module, and then we will do our as usual thing, that is our Q&A sessions, right? So let's start. So in this traffic control and management module, the topics that have been covered. So first, it talks about a brief background that why nowadays you need for this traffic control and management, because traditionally we built roads to manage the traffic. As soon as your congestion has been observed on the roads, or your vehicle demand increasing, so that time we traditionally want to build more roads, right? So why suddenly you need to have this traffic control and management? Because earlier it was done only at those instances where you already several times you build the road, you extend the road, and then actually you are trying to manage the traffic for the smoother traffic flow, right? So, but nowadays, if you see, traffic engineering itself, it became a complex thing. It's not a simple thing. First, it is now talks about multimodality, also involving of different modes, right? So nowadays, and also we build our cities in such a way that it's a kind of centralized systems. So most of the workplaces are concentrated in the CBD areas, that is central business district areas, right? In the metro cities like Kolkata, Delhi, Bangalore. We often heard that there are long queues observed in Bangalore, and the worst traffic that has been observed there, right? Even in the Hyderabad sometimes. So, so as we became this, or we uh, build our system in this centralized manner, so it is inevitable that people from the rural areas or small urban areas, they will actually come, uh, or they will shift to those urban locations, right? Due to the greater job opportunities, right? To build their career. And once they do this in large numbers, because already we know that in India population is uh, we are 1.4 billion people already, so population is continuously increasing, and also this kind of centralized urbanization is also happening, right? So obviously people are earning more, so they are purchasing vehicles more, sometimes two wheelers, sometimes four wheelers, based on their economic background. So now we see that we have built previously built roads, but they are not sufficient to accommodate that demand. So vehicle number is increasing uh, rapidly. So now there is a need that, or also in most of the cities, in most of the areas are not planned, not pre-planned in India. Even in the metropolitan cities, you will see that not all the areas within a metropolitan cities are planned. Maybe I think Chandigarh was the first planned city in India. So before that, the cities are like old Delhi, old Kolkata. They are not at all planned. So that's why we do not have that much of scope for road extension. So road is limited. Roadway, the uh, the 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 space, or the space that is available with the road agencies are actually limited. So as because it is limited, so there is no scope that we cannot extend the road further, right? So that's a one cause. Another cause is that generally some expensive this road extension sometimes is an expensive task also, right? So and also people, because we are going for work, so people are earning money, so economic well-being has come. So now people are more reluctant to reach the workplace smoothly within a reasonable time, so then they do not want to waste time, right? And also due to congestion there are several economical impacts as well, right? Economical as well as environmental. So with this background, there is a need to manage the demand or the traffic or the congestion, whatever you can say, uh, without building more roads, without extending it, because it may not be feasible at all times. So how do you want to manage the traffic? So here it's comes that you have to use traffic control and different management measures, right? So in this 21st century in India, it is at most and it is essential that we actually manage the traffic, right? So that our congestion is minimized, our environmental impact is minimized, our economic loss has been will be minimized. So and overall society will be in the on the side of the benefit, not on the side of loss, right? So with this view, so there is a need to learn about how to effectively do this traffic control and management, right? And there are several benefits as I have mentioned. So also traffic management, it can be done on urban roads or urban areas, right? Also there are some traffic management measure that has to be done on rural areas also. It may not be uh, all time required in rural areas, but sometime it is required, right? So suppose let's say there is an accident, right, along a national highway. So national highway, if you remember the road functional hierarchy classification, like functional hierarchy classification of roads, so you remember that national highway comes, right? National highway, state highway, and so on. So suppose there is an accident occurred in national highway, so it actually impacts the surrounding traffic, and it may lead to congestion, delay, and etc., right? So in that scenario, how do you manage the traffic? Also some other disruption could be, suppose we are maybe a part of the lane has to be repaired, right? So in that case also generally the work zone signings are there, right? Work zone, or maybe you are constructing something at that area, so in that case also your lane width reduced, that is your capacity has been reduced. So now you want to manage the traffic. So on those scenarios you want to use this traffic control and management measures in urban in rural areas as well, right? Apart from the urban areas. So broadly, if we say, there are four kinds of traffic management measures. First is the access management measures, then is the demand management measures, third one is the transit priority measures, and fourth, it's a what are the advanced traffic management measures, which actually uses sensors and intelligent transport systems, right, ITS and all. So first let's talk about the access management measures. So access management means, so you have to manage the access to a road. So what do you mean by access to a road? So uh, suppose there is a road and you provide access to a particular let's say okay, so there is some problem with my network. Okay, so let's wait for some time. why the network has been lost. Okay, so we have to wait because I lost my network, so we will wait for some time. Okay, let me share it once again. Okay, so we are discussing the access management. So suppose you provide access to a particular land parcel. Suppose there is a small parcel of land and you provided access through a lower category functional road to a national highway, right? So those access roads, right? So that has to be managed properly because if you are not managing those access points properly, what will happen is that your through traffic will be interrupted, right? So you want your through traffic to move faster, but it will interrupt by those access points. So you have to properly manage those access points. Also, there maybe sometimes it may happen that you have a access point and then you have an intersection nearby. So if this the scenario is like this, so because you have access point which is closer to the intersection, so there may be queuing and congestions, right? Because the distance is very less. So you have to think that what could be the distance from a intersection if you want to provide access point. How many access point actually do you need? So do you need access? Okay, so again the network is gone in the lab. Okay, it again came back, I think. So suppose uh, what do you mean by access? Access means you have to have access to those different land persons, right? So is it that do you want to provide access to each and every points through roads to the your national highways? See, if that is so maybe you have provided a good access, but your national highway, the operations or traffic operations on the national highway will be interrupted severe, right? So today there are lots of problem with the network due to the rain. Here actually the rain has started and it is actually causing the network to go down. Unfortunately, we have to wait for some time because I have lost connection. Okay, so I am back. Let me share it once again. Okay, so we were discussing that how to actually manage the access points, right? So then there is something called the demand management. So here demand management means too much vehicles means too much people on the vehicles, right? So you have to use some kind of demand management measures. So you can consider the high occupancy vehicles like car sharing, and the practical examples will be the services like Uber Pool, Ola Pool, those services, and even the bus, public transport, any sort of public transport, not only bus transport, whatever the rail transport, because there is a one vehicle and it is carrying more number of people, right? And it is because it is carrying more number of people, so there are less number of vehicles, and the one bus may be equivalent to some 30-40 vehicles even, right? Sometimes depending on the capacity of the bus. So those kinds of measures actually will reduce your number of vehicles on the road. So that is called the demand management. So you are managing or reducing the demand, right? Also, another example could be, suppose you are giving your employees work from home, right? Which is after COVID, which is the usual scenario in most of the, not most of the, but at least a few of the IT firms. Or if it is not purely work from home, so it may be a hybrid, like 2 days you have to work from home and then 3 days maybe you are attending office. So it's a kind of uh, rotating system, right? So you are not every day you are not going, so there will be less people ultimately on roads. So these kinds of measures actually comes under the demand management measures. So then third is the transit priority. So already we talked about the transit, anytime any kind of transit or bus. So it's a falling under demand management measures. So but still maybe because you want to travel faster, you want to reach on time, you want to give so you have to also public transport has to be reliable. So to improve those service quality of buses and to increase the attractiveness of the buses to the consumers or to the commuters, eh, there are some strategies which are called the transit priority strategies. So it is also traffic management strategies, because if you are reducing your one way travel or two way travel time, then actually you are using your resources effectively. So as for example, suppose you have 10 buses. So now suppose your planned time is that every 10 minutes bus will reach from A to B, and then B to A it will come with other than 10 minutes, and 5 minutes is layover. So ideally 20, within 25 minutes it should actually do a round trip, one round trip. So you have planned that my one vehicle will do a three round trips per day. Suppose you have planned like that. So now your uh, if your time increases, travel time, so maybe you cannot use, or maybe uh, like you cannot effectively use your 10 buses, because you have your sufficient, you have your fixed time. Say suppose morning 8 to evening 8 my bus will run, right? So after 8 I will not leave. So if your travel time increased and then it accumulates, so maybe you are seeing that your one bus at the end of the day it should run around 7:45, but it cannot run, right? Because you have already like because of the coordination. Or maybe then what happens, you may want to leave or depart two buses at the same time. So if you depart two buses at the same time, so whichever will depart at first, so it will carry all the passengers, and your next bus won't carry all the passengers, won't get too much of passengers, right? So these kinds of problems will also there. So it will lead to ultimately unequal use of your, or you can say that inefficient use of your fleet, and also it will increase the waiting time of the passengers as well, and the overall travel time. So to reduce that, we have to use some kind of transit priority measures. So what sort of transit priority? It may be signal based, so you are adjusting your signal in such a way so your buses are not actually facing much delay on signal. So usually what we see in urban areas, so buses are actually facing signal delays in signals most of the cases, right? If it's a signalized corridor in urban areas, you will see there are many signalized corridors. So now also there may be some kind of uh, separate exclusive bus lane design. So that lane is specifically for bus. So now buses do not have to travel with other traffics, right? So it can travel on a lane which is dedicated for the bus only. So now it will actually improve the travel time, so they won't face much delays. So these sorts of measures actually falls under the transit priority measures. Obviously we will go deeper, but not right now, so it is just a brief introduction. So then the emerging traffic management measures. So here emerging means currently, because of the 5G technology, good communications and sensor technology, and then we are using GPS technology. So because we have multitude of technologies, communication and telecommunication technologies, and also the IT technology, so we are combining those to create ITS, intelligent transportation system infrastructure, in vehicle or in urban mobility. So here actually we are using sensors and detector to improve our similar kind of strategies, right? So suppose access management strategies. So now we are using some kind of what can we say, some kind of sensors. Suppose we on a lane which is maybe having a signal, so it will channelize the flow of that particular lane, right? So based on that information of the sensor, actually it will decide that whether to give it a green or whether to give it a red, right? So those kinds of intelligent detecting and communication technologies are a part of this emerging traffic management schemes or the measures, right? So first it's the demand management measures. So there are I already talked about, there are many demand management measures. So this is not what I told, but one of the measures are the congestion pricing. So suppose usually people are going to work from home, right? And usually these workplaces are within the CBD areas of a urban area, right? So in or near the CBD areas, so you will see the congestion is very high. The travel time of vehicles are very high, right? So one of the options could be that for particular some of the roads within that CBD area, you may impose some kind of congestion pricing. So if a number of vehicles exceeds this value, so then you may impose congestion pricing. So whatever I told you, it's an example of dynamic, but maybe in static also you can say that from morning 8 to morning 12, which is the peak hour. So whichever the vehicles entered into the roads, they have to pay some kind of fee in the weekday because of the congestion. So which is called the congestion pricing, right? So now, not all the people or all the vehicle owners will want to give you money. So there will be automatically the demand will go down, and you are managing your congestion and improving your travel time, right? So or people might take some different routes, and maybe they will park somewhere and they want to walk in the some area, so something like that, right? So it is also managing your demand. So now already I discussed about use of transit, because one transit may carry 50, 40 to 60, even 70 if I consider bus, right? And on the road, one vehicle, generally we use personal vehicle, or one to two people maximum, right? So if you compare, so almost it equivalent to a 20 to 30 vehicles, right? It will reduce if people are using transit services like bus services, right? So that will actually reduce your vehicle demand. So another type of demand management strategies is ride sharing. So it is also the same concept. So you are using a bigger vehicle, so which have higher occupancies. So it will take more people, right? So obviously your number of vehicles will go down. So number of volume on the roads will go down, right? So it is called a ride sharing. So as for example, let's say Uber service, or previously it was named as, I think, telephonic service or something, which was famous in US. So you have to call, and then it's a call and ride or something. I actually forgot the exact term, but it was something like that. You have to call and pre-book, and it will come. So it is also a ride sharing service. Okay. See, even if you see in urban areas, many of the people who are staying nearby at least, and who are actually going to the same office or same school or same college, they used to book or use a certain type of shuttle services. Suppose there are 10, 12 people, so they hire a bolero, right? For regular Monday to Friday, and also while returning from the work, right? So those kinds of shuttle services, either bus or small vehicle services, like it is also falls under the ride sharing services. So now the flexible work schedule, that is also I explained. It is like you have to go maybe in a week 2 days to office, and then maybe you do not have to go, or you can remain 3 days at your home to do the work. And also some kind of because some kind of changing in the work hours. So suppose if you see that the congestion or these problems are majorly occurring during the peak hours, which is 9 to 12. So maybe you are designing, you have designed your starting of the work hour in such a way that suppose you have three shifts. So first shift people will join the office around maybe 7:30, right? And the second shift, maybe they will join around 12:30. Then maybe the third shift they will join around maybe 4 or something like that. So you actually are not traveling in the peak hours, and you have also reduced the demand, because suppose you have this much of employees, 15 employees, now you have divided into the pockets of 5 5 5 3 shifts. So this kind of things also falls under the flexible work schedules, right? So it is also actually flattens your demand curve, or reduces your demand basically. So then transit priority, that's what I am saying. So transit priority, it may include physical improvements. Suppose you want to build a uh, purely freeway type bus, separate grade segregated bus lane, right? So that time it involves obviously the physical components. You have to build a road, so it's a physical improvement. So now other thing is, if you want to change some kind of operating means here, maybe signal, or maybe you want to change the direction of flow. So there are many bus lanes which are actually doing this kind of operating uh, operating changes to improve your transit travel time, right? And also some kind of regulatory means, uh, suppose how means the rules, right? The so you have to use this lane for this lane for it, like that, right? So then it comes under the emerging traffic management. So already I discussed that it is nothing but to manage those three things: access management, demand management, and transit priority. But here actually we are using the automated and intelligent systems to manage the traffic. It is not static, because in real life also a demand and other things are not static. So based on the demand, based on the need, it will change, right? So suppose the example, one of the example is the setting of the dynamic speed limits, which actually you observe in the expressways, right? In the Hyderabad and different cities also, you will see the expressways, the dynamic speed limits signs are there. So it is actually sometimes dynamically changing, right? So it is changing based on the what is the traffic flow, what is the demand, what is the travel time is taking, is there any accident or not, is there any queuing occurring at some bottleneck points or not. So based on that actually it dynamically adjusts the speed. Okay, so do you have anything to ask based on whatever we discussed till now? So if no, then we can move forward. So access management strategies, let's discuss something regarding the access management strategies. So in case of access management strategies, so we already know this curve. So if I draw this thing, so like this, there is a curve. So if it is a mobility, or maybe this I can say mobility, and this I can say accessibility. So it is the expressways, and then the arterial, then the subarterial, then the collector, then the local. So this is the graph, mobility accessibility graph. So here if you see, for so so mobility is very high for expressways, right? Whereas for local street, accessibility is very high but mobility is very low. That means the vehicles are not traveling at much speed, but it is accessible to everyone, right? It is accessibility is very high. But whereas expressway you cannot access directly, right? So there are limited access points or to access the expressways. So whenever we talked about access management, so it is like for expressways, because the mobility is the main function, accessibility is not the main function. So here we want to provide lesser access. So obviously we want to manage access, many access points. The access points are also not too much. In case of arterial, there should be some kind of access points, because it's a lower level of mobility has been observed and some higher level of accessibility, but it is also not too high. Maybe it is greater than, if suppose along a stretch of an accessway, suppose you have provided only 2 access points, so maybe the same, if you have the same length of arterial at that particular location or the city or the urban area, so maybe you want to provide maybe 6 to 8 points, right? So we have sufficient number of points to access that arterial route, but it is not too much. It is not, it should not be 20, 25 like that. It should be in a limited range. So if, and also the placing, where you want to place, should it be in the intersection, like in case of expressway there should not be any access actually. These should be limited access only the entry and the exit. In between ideally there should not be, but maybe if there is something, so it should be limited. In case of arterial there will be access points obviously, because you have to access the road, but also we have to see that where the access point is, how do you want to merge the traffic. Is it that only you will allow the intersection traffic to merge, or you want to provide separate access point also, right? So these things has to be decided. So now there is something called the demand management. So already I talked about transit uses, right? So then van and carpooling. So van it's a bigger vehicle, car it's a smaller vehicle. So any kind of pooling service which uses, which actually where people can travel together, more than one people, 2, 3, 4, 5, 6, depending on the size or type of the vehicle. So that is actually reducing our demand, right? So more and more you want to use the transit, more and more you want to use the van and carpooling, right? In order to solve your congestion issues in the urban areas particularly. So again there are some special services which is a park and ride. So suppose you are, because many times your transit is not providing the door-to-door service. So suppose you have a vehicle, so you do not want to walk, right? You do not want to use other vehicles because maybe the accessibility or to those vehicles is not good, right? So maybe then you want to park, then you want to use your vehicles from home and then to park at some locations. So beyond that location, so maybe there is a metro, there is a good metro which will uh, which actually has a good frequency. So once you get there you will immediately get the metro. The service quality is very high, so ACs are running on, and also the speeds are very high, so you will reach maybe faster than your car sometimes, right? Because of the route maybe, right? So maybe those kinds of facilities may encourage people to use more and more those public transport facilities, right? So then also you want to provide incentives to the employees who are not using his vehicle and parking at the offices, right? So maybe whoever is using public transport more frequently, maybe they are maybe companies are giving them some incentives, right? So now it is encouraged. So suppose in a month, suppose only you have only a few times you have used your personal car to reach to the office, maybe 4 or 5 times. So maybe suppose your salary, if it is increased, so maybe you are more encouraged to use transit for your travel. So also the fare of the transit. So if government is providing subsidy to the fare of the transit on and with, with without compromising the actually quality of service of the transit, so that may actually encourage the commuters to use it, because now I have to pay less, and also I am reaching my destination on time. My waiting time is not so much, the reliability is good, I am getting a seat getting a seat to for traveling, right? So those kinds of things. So suppose so another thing is guaranteed ride home. So suppose some employees are doing night shifts, right? So obviously the security it's a issue in the night. So maybe especially girls, they want to use their personal vehicles if they have any, right? So in those cases, maybe you provide a special transit service, and you provide the proper security, right? You provide the guarantee that you will reach home comfortably and safe. So maybe people will use it. So then the flexible scheduling. Uh, so uh, so generally public transport are having a fixed scheduling. So now suppose you have uh, you you have some office buses uh, uh, which are actually whenever your work ends, you are getting immediately a bus. uh, may not be, you are not maybe traveling alone, but you are traveling with obviously your employees or colleagues. but maybe when offices ends on 3 at 3, that time also you are getting, and maybe whenever offices are ending at 4 at some days, some that time also you are getting some services from that office premises itself. So that will actually lead to encourage that will encourage actually the employees to use this transit and actually demand the and reduce the demand. So then congestion pricing, that's what I was discussing there. Suppose on certain roads, so you have to pay price due to the congestion. So if that is so, say you might want to take some alternative route, so that will lead to actually reduce the congestion on this road, also the next route, because if the congestion is increased on the alternate route, so there also congestion pricing will be applicable. So there will be some demand balance that will be automatically done. Just you have to provide the real time information to the passenger, so that road is congestion priced and that road is not, so maybe you want to divert your attention to those modes. So then variable tolling. So suppose peak hour, the along a particular route, your tolling rate increases during the peak hours, right? So as compared to the other routes and as compared to the other off peak periods. So that will also encourage people to maybe either not use vehicle or use one vehicle with proper planning between 2 3 4 employees, right? So you may be using one vehicle, one personal vehicle, but maybe using 3 4 people at a time. So those kinds of strategies may work, right, in the long run. So then also the parking, because parking it's a issue, right? So maybe offices are charging for parking, right? And some offices in the urban areas, because of the higher cost of the uh, higher cost of the apartments in the urban areas, so some office premises may not have the parking facilities, so you have to park somewhere else. Sometimes we are seeing the on street parking. So if you started charging those on street parking, or maybe you are not allowing it and you are providing some off street parking facilities and you are providing heavy charge, so people also may not or discourage to use the personal transit for their travel. So this sort of parking management measures can also be adopted. So then as I was discussing the bus priority measures, so there are specifically signal based bus priority and the space based bus priority, right? In signal based, you are doing some kind of interventions at the signal itself, right? And in case of space, so you are using your you want to use your road space optimally, so that you can prioritize the movement of the buses along the roads, right? So signal based is basically broadly it is of four types. First one is the passive signal uh, priority bus priority. So passive means here we are not using any detector, so we uh, use some kind of static uh, signal coordination as well as signal optimization to get a static plan, so that maximum number of buses will face less delay throughout the corridor, right? And we design our that particular corridor maybe. So that's a passive signal bus priority. So in case of active, obviously we are using sensors, or at least we are using GPS in the bus and also the sensors on the road. So once we know that bus is reaching nearby, so we want to change the signal, right, or modify the signal. So then real time is the advanced form of active priority itself, right? So here not only the we are detecting the buses, but also we are detecting the non-prioritized movement vehicles. So suppose buses are traveling along the priority lanes, right, or the priority directions. So there is a also a non-priority direction, right? So we want to detect both of those things and want to optimize the whole system, not the only the bus. Because if you want to uh, if you want to optimize the travel, or you have to you can or if you want to minimize the delay of the buses, sometimes you may lead to uh, increase it may lead to increased delay of the other movement, that is non priority movement vehicles, right? So real time signal based priority movements, priority bus priority actually attempts to solve with those issues. Then there is something called preemption. It is also like once vehicle reaches to the signal, immediately it gets the priority. It the your whole signal phase will change and it will give that vehicle priority. So generally, this kind of preemption, it may not be feasible in urban areas because it might increase the delay to other movement vehicles, right? So actually, it is like, even if you are on the backside on a signal, so it will give you the lane as well as the signal priority even sometimes. So such kind of priority is needed for emergency vehicles or ambulances, right, in rural areas mostly, but sometimes it may also be needed in urban areas, but it may increase the delay. That is a issue in the urban areas. So until and unless you have a serious situation, you do not want to design or use the preemption technique, right, in the urban area specifically. So do you have any questions until till this part? So another is the space based bus priority. So here either we can design busways. So busways are the great separated exclusive bus lanes, right? So it's like a busway that is specifically only for design for buses. So no other movement or no other vehicles are allowed to travel through that lane. Only buses will travel. So it's a separated thing. So generally in urban areas, because buses have to interact with the people on the roads, right? You have to travel. So this kind of busways are basically preferable in case of maybe regional bus services, right? Where you have only intermediate points where you need access, the rest of the things you do not need any kind of access. So that is called the busways. Then it is called the exclusive bus lanes. So exclusive bus lanes are the bus lanes which are also specifically designed for buses only. But here the main difference with the busways is it is on the lane itself. So you have a separate lane. It is not that separate grade separated. It is at the same grade, but it is a separate lane that is designed for buses. It is called the exclusive bus lanes. So obviously, because it is designed on the road, so in intersection it will also stop with other vehicles, right? So at intersections it will actually face some kind of delays, right? So therefore mobility will be, or quality of service or level of service of the buses are generally slightly lower than what you can observe in the busways, uh, due to uh, due to the obvious reasons, right? Then shared bus lanes are the bus lanes where we want to increase the use of that exclusive bus lane. So you have provided exclusive bus lane, but now you are thinking that because only buses are traveling and buses frequency maybe 10 minutes, so there is a space that some other sustainable mode of vehicles like uh, maybe bikes maybe e e-bikes, or maybe cycles like bicycles. So you can design your road in such a way, or maybe high occupancy vehicles along with buses can use that lane. So such kind of combinations, maybe increase the use of that bus lane and reduce the congestion at the nearby street as well, right? So this is called the shared bus lanes. So then there is something called the queue jumper lanes. So actually, buses, you see, so suppose it's a signal, so it's your road, right? So it's a suppose 2-lane road, it's a signal, right? So it's a signal. So now what happens, because uh, suppose it is a bus stop, so buses are serving passengers here, and then the signal turns red. So generally what happens, so buses are here only. So now buses are not only wait at the red signal, but also it will only clears this signal after these many vehicles or these queued vehicles will clear the vehicles, right? So not only signal delay, but also the congestion or queuing delay of vehicles. So to get rid of this queuing delay, because even if you are giving some kind of signal optimization or something, sometimes because of this unpredictable dwell time or serving of passengers, so it might happen that it is just join a queue of vehicles, right? So to solve that, what happens that sometimes some part of the lane or maybe one lane is near the intersection is dedicated. Suppose this length is dedicated to only bus, but only for this length. So no vehicles will enter this lane. So it is starting of the bus lane, right? And it is the ending. So vehicles will come, and like that it will queue here, and buses will come and directly go and serve, and sometimes even they can surpass the red signal, because I am not facing the queue, so sometimes I may go through this signalized intersection, and if it is not so, then also I will be standing here, right? So I can remove the queuing delay, right? So this is called the queue jumper lane concept. So I think these are this module is about theory only, so there are no problems. So only we will deal with the theories and the concepts, right? So now, so for signal or passive signal adjustment, what kind of actually interventions one can do? So either you can change your cycle length. So in signalized intersection module, so we know how to design a optimal cycle length, right? Using Webster formula, using the what other methods are also we are discussing now? That cycle maximum trial cycle method or something, that name. So based on that we will design what is our optimal cycle length. C, right? Optimal cycle length. So if we know that what is our optimal cycle length, so I want to change the cycle length itself. So I want to increase the cycle length so that buses are not facing delays. So now what will happen if you increase your cycle length too much? So then your delays will be higher. Delays to the other movement will be higher. So what about if you have some shorter cycle lengths? So if you have a shorter cycle length, so there will be so it's like vehicles will be queued because your cycle length is insufficient, and as your vehicles will be queued time to time, so there will be startup and those lost times will be accumulated. If you remember what is called the startup lost time, and then it will actually decreases the capacity of that intersection, signalized intersection. Other thing you can do the splitting of phases, right? So suppose you have this green and red phase. Now what you want to do, you because so these are context specific measures. We cannot say that this kind of measures will be helpful or not at a particular scenario, so you have to see. So sometimes it may happen that you see the our green is too large, so maybe if we can split the green and then give a small red and then give a green and then again give a red within that particular cycle itself, so then our bus movement is maximized. So if you see this kind of scenario, so maybe you will go for this splitting and readjustment of phases. So then also phase length. So suppose you have your different phases, one movement phases, two more here, maybe 30 seconds allocated for green. So maybe what you want to do, you want to change the phase length. So maybe here you design at 50, 30, 50 and 20, something like that, I don't know, something, some green times are 30, maybe 50. So maybe you want to give 50 here and 30 here because here is the priority bus movement is occurring, right? So this kinds of phase length adjustment you can do. Then area wide timing plans. So here area wide means, suppose this is your route consisting of one signal, two signal, three signal, four signal, like that, right? So it's a area wide, means it's a long route. So now you want to design your signal or optimize your signal in such a way so that uh, as we remember the one way progression and two way progression, so also we will include those progression concept into account, and you want to minimize the delay for the buses, right? So we will adjust the optimize our signal as well as we will adjust the those offsets so that the buses can smoothly move. So that is called the area wide timing plans, right? So now bypass metered signal. So suppose there are signal at a particular corridor which I was showing. So now you want to bypass that route and you want to use some other route to reach your destination, because that route do not comprise of any signal, right? That you can do. So it is called the bypass metered signal if it is feasible. So then also what we can do, you can design a special phase for buses. So whenever bus arrives, so there is a special phase which is dedicatedly given to the buses, right? So that you can do, maybe of 10 seconds you have given a special phase to the buses itself. Rest of the vehicles will be waiting, and you may want to design a special phase. Also the rerouting, like you want to bypass that metered signal, so you want to So now this is all about the passive priorities, right? Passive signal based bus priorities. So now if we come to the active signal based bus priorities, so there are many. So first is the green extension. So here as we discussed that there will be a sensor or GPS tracking device that will be installed in the bus. So we know when the buses arrive. So basically smart controller knows that bus is within 50 meters from the maybe stop line, right? So once we know that, we may want to extend the green. Suppose green is about to end, but we want to extend that green to certain seconds, right? So that is called the green extension. So then also suppose we bus went and bus is waiting at the queue, right, at the red signal. So if such is so, so suppose the 20 seconds is remaining, red time is remaining, so maybe immediately we want to uh, change our red phase to the green phase, right? Maybe we want to reduce our red to 10 seconds and we want to extend the green to again to some so to a few seconds, right? So those kinds of red truncations also can be helpful. So then altogether we can design a special phase. That's what I was telling, that whenever bus comes, I am giving it the green. So it's a kind of special phase I have designed for buses. Then also phase suppression means you want to suppress some other phase and you want to give that phase to bus. That is called the phase suppression. So then in case of real time signal based bus priorities, it's an advanced version. So it will check all the priority as well as non priority other vehicles, and then it will decide what is the optimal plan for the bus to so that passenger delays will be minimized. Okay, so that's what I told, that it is the real time, and in case of preemptions, I have written that only for rural it is mostly applicable and for emergency vehicles particularly. Right? So then there is something called facility based. This is what I already told, that in case of facility based we want to remove the queuing delay, because bus generally faces signal delay as well as the queuing delay. So we are actually removing that queuing delay part. So types of exclusive bus lanes. So already I told that there is a separate dedicated bus lanes for the buses we have designed, right? So, but there are several types of bus lane that you can design, right? So first is the with flow or concurrent bus lane. So means in which direction the vehicles are flowing, at that particular direction itself I have designed a separate exclusive bus lane. So that is the traditional one, right? Concurrent or with flow bus lane. So there are some situations where we have to design a contra flow or the mm, opposite direction to the general traffic bus lane. So buses are traveling on the opposite direction. So imagine the scenario where it's a one-way road, right? So it's a one-way traffic road you have to design due to the heavy flow at that particular direction, right? So but you see that buses have to uh, if buses are not using their particular road, buses may have to detour and come to their particular location. So maybe there you decide a lane width and you designated lane, and you have given that okay, buses may want to travel in the opposite direction using that small stretch, right? So that may so that may be the need for designing such kind of contra flow lanes. So then the reversible lanes. So here this the purpose of this lanes, that we have only designed one lane, one exclusive bus lane for the buses in the peak hour direction from home to work, and also that same lane we are using for the work to home purpose during in the evening peak, right? Morning peak it is going on the A to B direction, suppose north to east to west, right, or west to east, and during the second half whenever they are returning, commuters are returning to home, so it is coming from east to west, right? So we can change the direction of travel of those such kind of bus lanes. So then intermittent bus lanes are the bus lanes. Uh, it is actually not bus lane. So suppose you have a lane which is generally used by the normal traffic. So now you suppose you assess the need for the bus to travel faster. So you suddenly you change your lane to the intermediate lane, and suddenly that lane can no longer be used by other vehicles. It can be used by only buses, right, afterwards for some time. So it is called the intermittent bus lane. Also similarly, we can have some shared bus lane. So it may be by shared bus and bicycle, shared bus and bike, and etc. Right? So then queue jump lane also we have discussed, right? That what is called the queue jump lane. So now we come to the active traffic management. So here that's what I said, that everything is same. We want to here also we want to change the traffic control signal. We want to use our junction dynamically. The only difference is you want to do it with the use of sensors, communications, vehicle infrastructure communications. We want to use those kind of advanced technologies to manage the traffic, right? In case of suppose adaptive drum metering, suppose it's a highway and you have this ramp. So now we want to and it suppose there is an intersections also here. So now we want to use signal here. I want the detector to be placed here, also here. So based on the volume that is passing here, you have to decide that whether to pass or to allow the vehicles to merge to this main traffic or not. So those kinds of things are adaptive parametering. Based on the adaptive demand, or based on the changing demand, we want to do this, right? Also so we want to use dynamic speed limits, right? So speeds are based on the traffic conditions, queuing and those things. We want to change the speed limits. Also during peak hours, if we have some shoulders, so we can use those shoulders as an additional capacity during the peak hours to solve our traffic congestion problems, right? And also if there are queues that is there in the downstream, so maybe we want to put some kind of board and say that okay, the queues are ahead, so maybe you might want to avoid this particular route, right? So those kinds of things may also be there. Shantosh, I am busy right now, so maybe you want to come to the lab. If you want to come, you can come to the lab. I am busy right now. I am busy, so if you want to come, you can come to the lab. Okay. So then also the similar kind of thing in case of active demand management, we want to use the dynamic fare selections, reduction, dynamic ride sharing systems, and then in case of active parking management, we want to do this dynamic parking reservations. So you have a parking lot, now you don't know that whether you will be able to park or not, but here we are providing you dynamic parking information. So maybe this slot is free, so you want to go to this slot, so you are also not wasting your time, right? And also you are not unnecessarily queuing up there, right? So those kind of smart parking uh, uh, choices that is given using with the help of maybe smartphone or some other things, so will help you to find your parking places in a reasonable time. In the wayfinding, suppose you don't know the route, now you want to maybe travel along that route, but you don't know how to reach it, so maybe smart wayfinder maybe help you to reach that destination within the stipulated time. And also the dynamically priced parking. So now you know that if the already parking demands are high, so maybe the parking price has increased. So maybe I do not want to park here, so maybe I will park at some other locations and I will just walk back to the location or something like that. So this is in a nutshell the this week's content. So before I go to the Q&A, so maybe I will wait. So if you have any queries, you can ask. Then only I will go to the Q&A. So any queries, any questions are welcome. Before I start discussing the Q&A, any queries or questions? So then let's start the Q&A. I hope that you do not have any questions. So which of the following statements are true? In urban area, the morning and evening rush hours lead to increase in congestion. Okay, so obviously in urban areas we want to go from home to our work destination, that is that in most of the cases are situated in the CBD area. So obviously that rush leads to increase in congestion. That is true. Then the second one is rural areas may be susceptible to congestion due to recreational and seasonal activities, special event, festival. So generally, you may not see that morning and evening rush in the rural areas, right? But suppose there are special events like in West Bengal Durga Puja, or maybe in Maharashtra Ganesh Puja, like that, those festivals, right? So due to these festivals, or maybe sometimes due to bunds or strikes, right, of the political parties, Bharat bunds, so that will also actually lead to sometimes congestion, or those kind of things in rural areas, right? Uh, then daily travel to suburban areas may experience more congestion, daily commuters. Okay. No, because suburban areas you do not want to, uh, you generally do not experience uh, more congestion than urban areas, because urban areas are heavily congested due to the heavy demand and heavy population, right? Not the other way around. Suburban areas are relatively less congested as compared to the uh, urban areas. So it is not true. So first two is true, third one is not true, and the fourth one is limited options of travel in rural areas may lead to increase in delays. That will be there, because suppose you are waiting for much time because you are not getting a bus to ride. So obviously you are not able to reach on time. So it will obviously increase the delay. So these are the three correct options, right? So let us move to the next question. So which of the following statements are true with respect to the traffic management? Okay. So traffic management only applies to the routes with high traffic. It may not be necessary, right? Because it may be applied to the route where maybe accidents occurs, right? Maybe the traffic is not high, but maybe work zone is there, right? So those kinds of things, uh, like the, like maybe in urban areas, maybe we are building a metro, right? So we have closed uh, the maybe a significant portion of the total width of the carriageway, right? So that will also need the traffic management measures for managing the traffic, right? So then the traffic management measures cost more compared to the road expansion project. So because see, traffic management measures means what? Suppose we want to reroute, we want to change our signals, we want to impose parking pricing, we want to use congestion pricing. So these are not costly affairs to the government perspective, right? So these are not at all costly affairs. Maybe sometimes you may earn from these traffic management measures, but whereas road expansion projects are obviously costly. So if I remember, if we want to build a 1 kilometer road, so it costs crores, not in lakhs but in crores. So that is the cost of building a road. Hmm. So it is not true, but it is also not true, right? So unexpected delays can be reduced. Obviously, unexpected delays we want to reduce it. That is the main focus, right? So traffic flows are improved across the facility. Obviously, traffic flows will be reduced, and as it is improved, your delays will be reduced. So third is accept and reject type questions. So traditionally, operational improvements were preferred to physical improvement to solve congestion issues. So no, traditionally we were focused on building roads. That's what the previous question also tell. Na? Building more roads means the physical improvements, not the operations like signal change, direction one way, two way. So those kinds of things we are not considered traditionally. Traditionally, this building more lanes or physical improvements were considered. So it is a rejected. So it is rejected. So which of the following statements are true with respect to functional road hierarchy? So functional road hierarchy, if you remember, so it's like that: accessibility, mobility, accessibility, and like that, expressway and the local roads. So freeways operate at higher mobility compared to the other roads. Here freeways by expressways, mobility is highest for freeways. So that is true. Collector. The collector is operates here. See, collector road should have more mobility compared to the no. So the expressways. Then we are actually coming to the arterial. So arterial is having more mobility, not the collector roads. So the main function of local street is, this is the local street. Main function is to provide the accessibility, right? Accessibility to the different lands, properties. So that is true. So then the collector road should provide less accessibility compared to arterial roads. No, collector roads are providing more accessibility, right? Accessibility will be more. So this is also not true. So your 1 and your C will be true. Rest of the things are not true. So which of the following statements are true? Higher road classification maintained through traffic flows. Higher road classifications maintains higher mobility. Higher mobility means through traffic flow is high. So that is true. Appropriate access is maintained on lower road classification. That is also true. Appropriate access has been mentioned in this lower category roads. Access conflicts are more on higher road classifications. So access conflicts are more on higher road classification. It will be more on this because there are almost no access, but sometimes it may happen that your conflicts are high, but usually we tend to design it in such a way that your access points are not creating any conflicts, right? So this may not be true. So freeways should typically connect to local roads rather than arterials. No. So first, because first is freeway, then your arterial, and then your sub-arterial, and then your collector, and then your local. So because of this functional things, so your freeway should be connected to the arterial first. So it's a sequence. First freeway should be connected to the arterial, then arterial should be connected to the subarterial, subarterial should be connected to the collector, then it should be connected to the local state. So this is also not. So which of the following statements are true with respect to access management? Okay. So closely spaced uncoordinated signals improve the traffic flow. So if you remember the signal coordination in the next, I think in the 7th week, that signal coordination class. So if your signals are closely spaced and it is not uncoordinated, so it will face more delays. So it will not improve, but it will deteriorate the traffic flow. So it is not true. Inadequate corner clearance at intersections may lead to development of recurring queues. So suppose it's an intersection. So suppose it's an intersection and we are not getting the clearance. So here it's a building. So then obviously it will development of recurring queues because we are not able to see. So vehicle might slow down. It is also there is a chance of accident. So it is true. Driver should not be located outside the functional area of intersection. So driveways means the access points. It should not be here. It should located at a sufficient distance outside, because your driveways means there you have decided then whether to enter or not, right? So it should not be located in the functional area. It should be located, not should not be, it should be. The closer the driveway is located to each other, the more orderly is the traffic flow. This is also not true, because if the driveways are too closed, so there will be disordered traffic flow, not ordered traffic flow. So which of the following statements are true with respect to Edelman carpooling model? Okay, no, this is for last class. So here, which of the following statements are true with respect to demand management strategies? So demand management strategies encourage a shift from non-SOV trips to SOV trips. SOV means single occupation vehicle, not HOV. It is not HOV, which is high, and AC means single occupation vehicles. So to SOV is not true. It will encourage people to go to SOV to non-SOV, right? So we do not want to use single occupancy vehicle. We want to use high occupancy vehicles. Shift private trips to off-peak periods. Yes. So we want to shift the private trips to off-peak periods by using the demand management measures. So then 6, to reduce the private automobile trips. Yes, because we want to encourage the uses of carpool, vanpool, public transport, paratransit, right? So obviously we want to encourage that. Usually implemented by employees, public agencies. Employers can actually do that. Public agencies also can implement this demand management strategies. We cannot say that they will only do it, because government also have some role in doing it, because they may be implementing it, but government will impose the rule sometimes. So which of the following statements are true with respect to employer based stadium strategies? When you want to motivate the employer, that is the employer based strategies. So encourage to travel via non-SOV modes. Non-SOV means you can say HOV mode. That is true. So then shift private trips to peak periods. Yes, that is the intention only. 6, to eliminate some of the work strip via telecommunicating means work from home types, right? So obviously that is the employer based strategy. Providing transit subsidies to employees may lead to costlier perception of, yes, because if for some employee we are giving transit subsidy, so it may also lead to costlier perception that okay, SOV tips are very costly because they are providing them the transit at a reasonable cost with a good service, right? So this is also true. So this is also true. So then the next is, which of the following statements are true with respect to congestion pricing? So congestion pricing is similar to traditional tolling. No, tolling is generally traditional tolling. It's a fixed price. It's not a variable price. But in case of congestion pricing, it is not applicable to all the time. It is only applicable during the congested periods only. Sometimes in real time, or sometimes it may be static. They would have decided that due to this period we want to use congestion pricing, right? So it is not the traditional trolling, but modern trolling actually does the kind of same thing. So intends to reduce private vehicle trips by providing disincentives. Intends to reduce private vehicle trips by providing disincentive. Okay, so it intends to reduce means by penalizing them. That is the thing. We are not providing them incentives, sorry, but we want to charge it for using the road. So that is true. Encourage people to think whether trip can be made at different time or in a different way. That is also true, because during a particular time, so you have imposed congestion pricing, so they have to pay. So they are thinking that should I postpone my trip to the non-congested periods where congestion pricing is not applicable, or maybe should I use some other roads to travel, or should I use some other means using some other modes to travel, like public transport, which is a relatively cheaper mode, and you do not have to worry about congestion pricing and all, right? So those can be done. It leads to reduced delay for essential vehicles. Because now your see, whenever congestion pricing in place for a particular road, so what will happen that if someone is not going to work, or it is not necessary for him to travel, say they may not travel actually, so it will actually eventually reduce the delay for the essential work trips or those vehicles, right? Even for the emergency vehicles as well. So it is true. So this is the week 9 whole thing that I have designed. So actually today I went through the Q&A sessions a little bit in a quicker way, because already I have discussed so many things, and it's only a Q&A theoretical thing, not a numerical thing, and also theoretical based. Mostly it is a information based theory, right? You do not have to understand that much at least. So that's why I went it relatively in a quicker way. So I think you will be able to grasp it in a reasonable, in a grasp it, and you will be able to perform in a good manner, and it will help you to solve your assignments, as well as it will help you to perform better in your final NPTEL exams, right? So if you have something you can ask. If you do not have anything, then actually I will close the session for today. And I think we have remaining 3 weeks. 2 weeks will be on safety, and the last or remaining week will be the overall what we learned in this traffic engineering course. Is a kind of quick uh, briefing of the overall content, and if you have any questions for from any of the modules, so you are actually feel free, you can feel free to ask, right? So if you do not have anything, should I close the session? So if you have uh, no questions to answer, or what you want me to answer, so then I will be closing the session for today. Okay, then I am closing the session for today.